Yes, thank you for coming to this talk, everyone. Yeah, titled Mercari LLM Benchmark. Yeah, in this talk, I show the importance of building benchmark tasks in LLM for your business, and technical details of developing evaluation pipeline for LLMs. Also, to start, let me quickly introduce the company Mercari. Yeah, since some of you may not know us. We are providing the largest C2C marketplace in Japan, where people can list items at the price they want, and the users can buy them if they feel that's good. This is the example in Mercari, and this is a PyCon, so this is the example book of Python. Yeah. Such kind of can be buy in Mercari. Yeah, so you can eat on both mobile application and website. Yeah, and coincidentally, since May of this year, Mercari became available in Hong Kong recently. Yeah, so people in Hong Kong can purchase items listed in Japan. So if you are interested, please give it a try. And next, let me introduce about me. Yeah, I'm Kanta Suga from Japan. I'm working as a machine learning engineer on Mercari's safety ML team. In there, I'm developing ML models that for content moderation. Yeah, I finished my master's course in bioinformatics this March and joined Mercari as a new grad engineer in this April. So please go easy on me today. Yeah, here is the agenda for today's discussion session. Yeah. And let's start with motivation section. First, recently, huge amount of LLM models were released from any kind of providers. For example, OpenAI released GPT-5 and Mini, Nano, and 2025 August 7, blah, blah, blah. And those kind of streaming models. Yeah. On the other hand, Anthropic also released Cloud Sonnet 4.5 and Cloud Opus 4, Cloud 4.1, Sonnet version of this, and blah, blah, blah. Similar things happen in Google Gemini series. Surprisingly, all those models were released in just the past 1 or 2 years. Then I think many of you have probably wondered which model could be most effective for your own business. Yeah, when it comes to evaluate and compare the performance of LLM, there are some major benchmark tasks. For example, MMLU, that's for measuring general language understanding ability. As an example, MT-Bench is for measuring conversational ability of LLMs. And recently, it's hot topic SWE Bench. It can measure the capability of coding agents like Copilot, Cursor, and Cloud Code. Yes, and so on. As shown in the right figure, this is an example from Anthropic Sonnet 4.5, which provides strongly emphasizes how well their models performed on their major benchmarks like these. Here, we are at the implementation of the current benchmarks for LLMs. First, all major benchmarks are English-centric. Even if a model performs well on English benchmark, that doesn't necessarily mean it will achieve similar performance in other languages. Second, since LLMs are trained on massive amount of text collected from various sources on the internet, so there is a risk of contamination of information. Yeah. And in addition, as model providers have recently tried to emphasize achieving high scores of major benchmarkings, so there's a growing risk of overfitting to those benches. Third, there's a gap between benchmark and production, I think. Benchmarking is just benchmark, so when we try to apply models to actual business tasks, we often find a performance gap between benchmark result and real-world application. So now let's take a look back and think about what kind of company Mercari was. We are a Japanese company running a unique C2C e-commerce platform. So there are a few companies doing similar things. Therefore, we want to bring when we want to bring LLMs into our production, we have to address those limitations I mentioned just before. So we decided to build our own benchmark tasks tailored to our use cases and evaluate models against them. We think that gives us several benefits. First, the most important aspect of creating our own benchmark is that it allows us to directly measure business-linked KPIs. From a business perspective, not only the accuracy, but also the cost and latency are critical factors, I think. And so by creating our own benchmark, we can measure these KPIs as well, and make it easier to consider business implementation. Another benefit is that a homemade benchmark lets us keep up with frequent model release. As I said before, new LLMs are released at an incredible pace. So if we own the task and the pipeline, we can quickly decide whether the new model is worth replacing to the current one. Lastly, by owning our own benchmark, we can evaluate LLM's performance for our specific language and domain. With those motivations, we build custom tasks and the evaluation pipeline for original benchmarking. Then let's see our evaluation pipeline. Here is a brief article of benchmarking pipelines. So this pipeline consists of three main growth sections. First, configuration of inputs, a pipeline runner, and database storage. And then let's first start with how to build tasks in this pipeline. In a pipeline, each task can be defined by a runtime file like this. The file names should be standardized like 001.md and 002.md and so on. The first section holds the task metadata. And this is a section for how to this task to be treated. In the metadata, we can define many things. For example, task ID, description, and expected answers, and also extract and checkers, as those are explained later details. And we can specify even further to use case-shot examples or chain of thought reasoning in when calling LLMs. So this flexible model configuration is one of the highlights of this pipeline. So the rest part of task code is the prompt body. The text we pass to LLMs. Keeping the metadata and the prompt in one file is a good property of this setup, I think. And so next, let's see the example tasks we created. We have set two tasks based on actual use case within our company. Customer inquiries case and item moderation case. Now let's dive into each. The first task is customer inquiries. As our company receives a massive number of inquiries daily from customers about buying and selling products. Each inquiry has a certain level of difficulty. For example, like inquiry 1, as it says, I forgot my login password. Those can be handled by less experienced customer support staff, I think. But in case of high difficulty inquiries, like inquiry 2, I was scammed in Mercari, so I'm going to sue you through a lawyer. It requires so these kind of things often happen in our company. It requires staff with advanced knowledge to handle them. To address this situation, our team is developing machine learning methods to classify the difficulty of inquiries. This is the first task. The second task is item moderation. On Mercari, users can list items like bad or false, illegal or dangerous items are prohibited. For example, guns, swords, knives, and even sexual items. Approximately 1 million items are listed on our platform in each day, making it impossible to manually check every single listing. So we have to classify listed items whether it's prohibited with ML models based on their listed images and product descriptions. And it would be simple if we can ban everything suspicious items, but we have detailed guidelines defining what can or cannot be listed. In case of this figure, it looks user listed a gun. And checking the item description, it says this is a toy gun. So toy gun is not prohibited by our guidelines. So model have to classify it as no, not prohibited. And like this, we will feed these guidelines and the item description to the LLM simultaneously and instructing it to classify whether a given item is prohibited. This is the second task. Here, I have to explain two important philosophies for constructing tasks. The first one is task uniqueness. When evaluating LLM performance, a task must be as diverse as possible. For example, in our customer inquiry task, a good task setting is like that. In task A, where the customer claims they will take legal action, and in task B, where the customer states they will consult customer affairs. This task division is good because it forces LLM to consider different reasoning paths. On the other hand, a bad example would be like that. In task A, the inquiry is that a purchased camera is broken, and in task B, purchased handbag is broken. While these cases seem different, LLM don't need to think the different action cases. So this means lacking of diversity. So this example might be overly specific to our company, but it shows that when creating benchmark tasks, ensuring diversity is crucial. Another critical aspect is PII anonymization. PII stands for personally identifiable information. For example, customer inquiries often contain significant PII, such as usernames, address, real names, use date, item ID, and so on. Passing those information to LLM without masking leads to some leaking of personal data to each provider, such as OpenAI and Kagi. So this is why we need PII anonymization. This is an example of anonymization in our task, where we meticulously make masks details such as user's name, case ID, and even the date of inquiry. And during masking, we replaced the original PII word with redacted blah blah tokens. And so thank you for listening. That's all of the way how to construct tasks in our benchmarking pipeline. And next, let's see the technical details of the evaluation pipeline. First, let's start with the most core part, how to calling LLMs. In this pipeline, we invoke multiple LLMs with a tool called Light LLM, which is a Python library developed by Berry AI. Light LLM is a kind of proxy server. By using this, you can call over 100 different LLMs with just this simple code written in left side code. And so a key feature of this library is that it enables us to unify input-output format into the open AI format for any LLMs you call. So this feature makes benchmarking across various LLMs much easier. And then we can manage models to use in benchmark with a single JSON file, like this. This models.json file contains a model ID on light LLM and the display names on the pipeline, and so on. Additionally, by including the cost per million tokens for each LLM in here, you can compare even the monetary cost of LLMs. An interesting point is that even parameters like listening effort and temperature can be specified in these config files. Listening effort specifies how the code LLM treats the thinking process, and for temperature adjusts the randomness of the LLM's output sentence. By making these parameters adjustable as well, benchmarking can be tailored more closely to real-world application. So during benchmarking, we call multiple LLMs. Our implementation enables concurrent LLM code by utilizing async function combined with light LLM. And furthermore, since each LLM provider has rate limit or such kind of things, so we simultaneously control maximum concurrency using semaphores. Then next is the explanation of the evaluator. The evaluator consists of two components, the extractor and checker. At first, the extractor corrects inconsistency of output across different LLMs and standardizes the responses. I'm sure most of you experienced that response from LLM frequently fluctuate. For example, in a task, the response from LLM A is like this. The answer is in escalation true. Here T is capitalized version. Meanwhile, LLM B outputs need escalation true. This is with a lowercase t in true. So to evaluate these outputs fairly, the extractor is necessary, I think. The extractor extracts the required part from each LLM's response and converts them into the information and is for valid answer. In this example, it needs to be converted to a Boolean type of true or false. On the other hand, the checker doesn't perform complex tasks, but it verifies whether the standardized responses from extractor matches the answer defined in the task code. And this combination of extractor and checker enables us to evaluate LLM accuracy fairly. As a final step in the pipeline, I'll explain the feature for logging result to the database. When running this pipeline, it automatically builds an SQL database, where all benchmarking progress and responses from the LLMs are stored. The database schema includes run ID, task ID, and model ID as a primary keys. And also we call the LLMs raw output, monetary cost, and latency, and other metrics. And so you can check the results saved in the database like this. And saving the result as a database makes it easier to analyze the result using SQL queries. But furthermore, since progress is logged in the database, even if benchmarking stops in the middle, it can be resumed from that point with queries. By running the running code with resume option, a query is executed to extract jobs that have not yet completed. So this feature eliminates unnecessary cost of calling the LLMs twice or more time. in your benchmarking session. Yeah, and that's all the technical details of the evaluation pipeline we built. And to recap, first, tasks are created in Markdown, and the models for benchmarking are specified in JSON config. By running runner, you invoke write LLM to test models from any providers. Then finally, results are stored in an SQLite database. And this makes it easy to research benchmarking and compare results effortlessly. Yeah, that's all evaluation pipeline. Then finally, I'd like to show the result of testing this pipeline with our own tasks. We evaluated a total of 16 models across 18 tasks. We say 16 models because we have 8 LLMs listed in here, for example, GPT-5 Nano, Mini, Gemini, or such kind of things. And each LLM has both light and low reasoning effort settings, as I said in the model configuration section. So it leads to 16 models in total. And then this is the result sorted by accuracy. From an accuracy perspective, Gemini 2.5 Pro, one casing version, achieves the highest performance. I think this is an interesting result because generally GPT-5 and Cloud Opus 4.5 are considered to have highest performance currently in the world. And so if we hadn't conducted this benchmarking, we might have incorporated those models, GPT-5, Cloud 4.5, into our business without further thought. However, we found that this Gemini model performs best for our specific task. So this is one of the key benefits of conducting benchmarking by ourselves. And the most important point is that when you look at the benchmarking result from the perspective of cost and latency versus an accuracy, you can see that the Gemini 2.5 flash write 1K sync version model performed the best. Moreover, its accuracy is not significantly different from Gemini 2.5 Pro, the best accuracy model. And so if your business prioritizes monetary cost or latency over accuracy, then Gemini 2.5 flash write is a model you should use. This is arguably the most significant benefit of conducting your own benchmarking. So if latency is crucial for your business, so plot graph like this, accuracy versus latency, and to find the model with the optimal trade-off between those. And similar things can be conducted in API cost and total cost things. Created a similar graph and compare the trade-off of accuracy and total cost, and you can select the models which feel the best balance. This is a really final section. Here's a summary. What we learned from this benchmarking and what I want to tell you today are those. First, having a benchmark with even 10 tasks is better than having no benchmarking. And then keep the evaluation pipeline simple and make direct API calls to LLMs instead of using frameworks. And so if you think this talk could be helpful in your business, please try building your own benchmarks. Thank you for attention.